Today we're going to look at using the addition rule in probability. And the learning goals is that what we're going to be able to do is use a new rule called the addition rule to determine probabilities of the union of two events. So the addition rule is given as the probability to determine the probability of the intersection of two events. It's going to be equal to the probability of one event plus the probability of the other, and subtracting away the intersection, the ones that are common to both. So if we actually have a look at what how that might be represented in a Venn diagram, we can see that we're trying to find the union. Okay, so the union, that's parts that are A and B or both. So if we have a look at the probability of A, that includes the intersection. B includes the intersection as well. So what we would be doing if we just added the probability of A and the probability of B together is that we would be doubling up on this middle section here. So what we need to do is we need to subtract the probability of the intersection actually occurring away, so that we're left with the probability of A only, the probability of B only, and the intersection all combined together. So that's where this rule comes from. And if you are ever stuck on remembering what the rule is, just think about the Venn diagram, or draw a little Venn diagram so you can add those two bits together and see that, okay, I need to subtract that middle bit as well. So the probability of, if two events are mutually exclusive, remember that means that the intersection of A and B is the null set. So that means there is a zero probability that it will occur. There is no probability that there's no possibility that anything could occur inside that zone. They are mutually exclusive. There's nothing connecting them. So that means all we need to do to find the probability of the union of A and B is to add those two together, because there's no intersection, and that's represented in this diagram here, that A and B are mutually exclusive. We just add those two probabilities together. So let's look at an example here. We've got a normal pack of 52 playing cards, so 52 playing cards. So that means there's 4 suits, 13 cards in each suit, ranging from the numbers 2 through to 10. We get the picture cards as well, Jack, Queen, King, and we get an ace as well. So A is the event, the card is a diamond. And B is the event, the card is a jack. So if we're looking for finding, we're being asked to find firstly the probability of A. So for A part I, the probability of A, this is the probability of a jack, the probability that the card is a diamond. So the number of total possible outcomes is 52. How many diamonds are actually in the pack? How many favourable outcomes are there? Well, there is one quarter of them, so 13 of those cards are diamonds. That means the probability of it being a diamond is 1/4. If we have here looking for the probability of B, this is the card is a jack. There are 4 jacks in the deck of cards, one for each of the suits. So that means we have a probability of 4 out of 52 total cards. That's 1/13. Lastly, we're asked for 1, 2, 3, the probability that it is both a jack and a diamond. The probability that it is both a jack and a diamond. So the probability that it's both a jack and a diamond is 1. There is 1 jack of diamonds in the whole pack. So it's going to be 1 out of the 52. So now if we're going to use the addition rule, to answer B, it says use it to find the probability that of A union B. So this is the probability of it being a diamond or a jack of diamonds. So that means in order to use the addition rule, we need to have the probability of A plus the probability of B minus the probability of A intersection B. So the probability of A was 1/4. The probability of B was 1/13. and the probability of A intersection B is 1 card out of the 52. And if we calculate that, we get that the probability is going to be 4 out of 13. Okay, so that's the probability that it's going to be a diamond or a jack or the jack of diamonds. Let's have a look at C. We're asked now to find the probability that the card is a jack or not a diamond. So the probability the card is a jack or not a diamond. So what we're looking for here, we're finding the probability that it is a jack. So the card is a jack is the probability of B occurring, or means we're looking for the union between both. Not a diamond, the card not a diamond is a dash. So we can just use our addition rule here. Probability of B plus the probability of not A minus the probability, of the intersection of not A and B. Probability of the intersection of not A and B. Now we calculated the probability of B before, that's 1 out of 13. The probability of not A means that if the probability of A is 1/4, then the probability of not A is 3/4, because it has to add up to 1. The probability of A and the probability of not A must equal 1. So if the probability of A is 1/4, then the probability of not A must be 3/4 to be able to add up to that. Now the intersection between the probability of the intersection between not A and B. Not A is the card is not a diamond. So how many cards are not diamonds? Well, we've got there are 3/4 of the pack are not diamonds, and the card being a jack, there are 3 jacks in the pack that are not diamonds. So that's 3 out of 52. So there are 3 cards that are jacks but are not diamonds. So then if we add up these probabilities and subtract away our 3 over 52, we get that the probability of a card being a jack and not a diamond is 10 over 13. So let's review the learning goal. The learning goal for this lesson is just to be able to use the addition rule to be able to determine the union between 2 different sets.